Have you ever gazed up at the night sky, tracing the constellations with your eyes, and wondered how it all began? For millennia, humanity has looked to the stars, driven by an insatiable curiosity to understand our place in the cosmos. We have built telescopes, sent probes to distant worlds, and devised intricate theories to explain the birth of stars, the formation of galaxies, and the very origins of existence itself. Yet, what if the answers we seek aren't written in the stars above us, but hidden in the fabric of reality, even before our universe flickered into being? Today, we're venturing beyond conventional astronomy and physics to explore one of the most profound and startling ideas ever conceived: that advanced technologies might not only exist beyond our world, but may have actually predated the universe as we know it. It sounds like science fiction, but leading cosmologists, philosophers, and futurists are asking whether the first technologies didn't emerge within our universe, but instead shaped it from the outside, like cosmic architects laying the groundwork for reality itself. In this video, we'll uncover 30 groundbreaking theories about the universe's first technologies, ideas that challenge our understanding of time, existence, and innovation. From primordial code embedded in the laws of physics to technologies so advanced they operate outside space-time, we're about to embark on a journey that will stretch your imagination to its limits. This isn't just a list of far-out concepts, it's an exploration of what might lie at the very foundation of everything. So settle in, open your mind, and get ready to see the cosmos and technology in a whole new light. Our journey begins with a theory that reimagines the Big Bang not as a chaotic explosion, but as the deliberate execution of a cosmic command. This is the idea of the cosmic seed algorithm. Think of it not as a piece of software running on a computer we could recognize, but as a fundamental, primordial set of instructions, a recipe for reality itself. Proponents of this theory suggest that before the concepts of space and time even existed, this foundational code was activated, initiating the expansion of our universe and meticulously governing its earliest moments. It's the ultimate bootstrap program, the first and most important technology, whose sole function was to generate existence from nothingness. This algorithm wouldn't be written in Python or C++, but in the language of mathematics and fundamental physics. It would be the source code that defines everything from the strength of gravity to the mass of an electron. This provides a potential solution to the infamous fine-tuning problem in cosmology. Why do the universal constants have such precise, life-permitting values? If the force of gravity were even slightly stronger, the universe would have collapsed back on itself immediately. If it were weaker, stars and galaxies never would have formed. From this perspective, these values aren't a random cosmic lottery win, but the carefully chosen parameters of the seed algorithm. The mathematical elegance and order we observe in the laws of physics are not happy accidents. They are the elegant design of this primordial program. Consider the cosmic microwave background radiation, the faint afterglow of the Big Bang. To us, it's a snapshot of the infant universe. But to a theorist considering this idea, it might resemble the output of a complex simulation, a thermal signature left by the initial processing of the algorithm. The immense gravitational wells of dark matter that sculpt galaxies could be seen as the underlying architecture, the framework upon which the visible universe is built. In this view, every galaxy, star, and planet is not merely a physical object, but a manifestation of this ancient, executing code. We are living inside the greatest computation ever run, a process that began an estimated 13.8 billion years ago and continues to unfold all around us in every moment. But if the universe began with a line of code, where was it being executed? This leads us to a second, even more mind-bending possibility, that the very quantum foam from which our cosmos emerged was not a chaotic, random sea, but a carefully engineered substrate. This is the quantum genesis framework. Conventional physics tells us that our universe likely sprang from a quantum fluctuation in a pre-existing vacuum, a random event in a sea of nothingness. But this theory proposes that those fluctuations weren't random at all. Instead, they were the product of an advanced technological process, a manipulation of reality's most fundamental layer to produce a specific, stable outcome. Imagine the pre-universe state not as pure emptiness, but as a field of immense potential, like a blank canvas humming with invisible energy. Within this framework, a technology of unimaginable sophistication could have targeted this vacuum, inducing a controlled fluctuation of precisely the right magnitude and characteristics. This wouldn't be a random spark, it would be a deliberate ignition. This guided event would then set off the period of hyper-expansion we call cosmic inflation, a process that had to be exquisitely fine-tuned to create the large-scale structure we see in the universe today. Inflation had to start at exactly the right moment, expand at exactly the right rate, and shut off with pinpoint precision. The quantum genesis framework suggests this wasn't a lucky break but a programmed sequence. The evidence for this might be written into the fabric of the cosmos itself. The stunning uniformity of the cosmic microwave background, where the temperature of the universe is the same in every direction we look, is a direct prediction of inflation. From the perspective of this theory, this isn't just a fortunate outcome, it's a signature of a controlled launch. Furthermore, the minuscule quantum fluctuations that were magnified during inflation to eventually form galaxies and galaxy clusters could be seen as the intended result of this process, the deliberate introduction of a specific type of noise into the system to ensure structure would form later on. The first particles and forces themselves, quarks, electrons, photons, the strong and weak nuclear forces may not have been accidental emergences, but the intended, stable products of this genesis technology, each one a necessary component in the grand architecture of a functioning universe. This brings us to a third, paradigm-shifting concept that challenges our most basic perception of reality, that the three spatial dimensions we experience are not a fundamental given, but a meticulously crafted product. This is the theory of dimensional engineering. It proposes that our universe was intentionally constructed within a stable, three-dimensional framework, carefully carved out from a far more complex and potentially chaotic higher dimensional existence. The beings or processes behind this would possess a technology so profound it could manipulate the very dimensionality of space-time itself, selecting for the specific parameters that allow for complex structures like atoms, planets, and life to exist. To grasp this, we must venture into the realms of string theory and brain cosmology. These are not just abstract mathematical playgrounds, they provide a potential blueprint for how such engineering could work. String theory suggests that the fundamental building blocks of reality are not point-like particles but tiny, vibrating strings. Crucially, for the math to work, these strings vibrate in a reality that has 10 or even 11 dimensions. So where are the extra 7? Theorists propose they are compactified, or curled up into sizes so infinitesimally small that they are completely hidden from our perception. Dimensional engineering takes this a step further, asking, what if this specific configuration of 3 large, expansive dimensions and several tiny, curled-up ones wasn't a random outcome of cosmic evolution, but a deliberate design choice? A stable, life-friendly universe might only be possible with this exact dimensional recipe. Any other arrangement could result in forces that don't hold together, particles that can't form, or a reality that instantly collapses. Brain cosmology offers an even more vivid picture. It proposes that our entire universe might be a three-dimensional membrane or brain floating within a higher dimensional bulk. Imagine our reality as a single, immense page of a book existing within a vast library of other pages. From this perspective, the Big Bang itself could have been the result of a collision between 2 such brains in the higher dimensional bulk, a collision that wasn't a random accident, but a controlled event initiated to release precisely the right amount of energy to inflate a new, stable brane universe. The technology required to orchestrate such an event is beyond our comprehension, involving the ability to navigate and manipulate these hidden dimensions. What evidence could possibly support such a fantastical idea? The clues might be hidden in the very laws of physics we are still trying to decode. The mathematical elegance we see, the fact that the universe is not only comprehensible but also governed by laws that can be written down on a napkin, points toward a deep underlying structure. Furthermore, if these higher dimensions do exist, even in a compactified state, they might leave faint imprints on our reality. Particle accelerators like the Large Hadron Collider are, in part, searching for evidence of these extra dimensions by looking for particles that occasionally leak through or for missing energy that might have drifted into them. The discovery of such a signature wouldn't just confirm a theory in physics. It could potentially be the first piece of forensic evidence for a universe that was built, not born. But if the dimensions of space can be engineered, what about the very fabric of time? This leads us to a fourth theory, one that might be the most disorienting yet, the concept of temporal architecture. We experience time as an unwavering, linear flow from past to future, the so-called arrow of time. It feels as fundamental and undeniable as gravity. But what if this flow isn't a basic feature of the cosmos? What if instead, time as we know it is a sophisticated technological construct, a carefully architected system designed to create a stable, causal environment for complex structures like galaxies, planets, and life to evolve? This theory posits that the primordial state before our universe may have been a realm of true timelessness, or a state where time was a tangled, multi-directional mess without any consistent flow. From this chaos, a process of temporal engineering could have established the unidirectional arrow we take for granted. This wouldn't involve building clocks, but rather establishing the foundational laws of thermodynamics and quantum mechanics that enforce causality. The fact that we remember the past but not the future, that eggs scramble but never unscramble, that entropy always increases, these aren't just observations. From this perspective, they could be the intended features of a system designed to prevent paradox and ensure a coherent, stable timeline. The implications of this are staggering. It suggests that the initial conditions of the Big Bang were set not just with spatial parameters but with temporal ones. The incredibly low entropy state of the early universe, which physicists call the past hypothesis, is the reason the arrow of time exists. It's like winding up a clock. The universe was given a single, powerful spring that has been unwinding for billions of years, driving the flow of time forward. Temporal architecture proposes this wasn't a lucky initial condition, but a deliberate setting. It was the first and most crucial clockwork, wound up and set in motion to allow for the possibility of history itself. This view also radically reinterprets the potential for time travel. The laws of physics, as we currently understand them, don't explicitly forbid traveling to the past, but they throw up immense practical and logical barriers, like the need for exotic matter or infinitely long cylinders. If time is a fundamental property, these barriers might be insurmountable. But if time is an engineered technology, these barriers could be seen as built-in safety features. Causality, the principle that cause must precede effect, is the ultimate operating system of our universe, preventing paradoxes that would crash the entire system. The difficulty of time travel might not be a limitation of our engineering, but a design feature of a cosmos built for stability. Any technology capable of circumventing this would not just be bending a natural law, it would be hacking the universe's core programming. Evidence for this audacious idea might be found in the deepest puzzles of quantum mechanics. At the quantum level, the distinction between past and future becomes blurry. The equations work just as well forwards as they do backwards. Yet, when quantum systems interact with the larger world, they collapse into a single state, solidifying the arrow of time. This transition from a timeless quantum realm to a time-bound classical world could be interpreted as the point where the temporal architecture takes over, translating potentiality into actual history. Furthermore, the relentless expansion of the universe, driven by dark energy, is intrinsically linked to the flow of time. As space stretches, it provides more room for entropy to increase, reinforcing the arrow. This cosmic connection between space and time could be the hallmark of an integrated design, a unified temporal spatial technology working in perfect harmony to create the stable reality we call home. Building on the idea that the universe's very structure and flow of time might be engineered, we arrive at a theory that draws a stunning parallel with the most sophisticated information system we know of right here on Earth, the blueprint of life itself. This is the concept of cosmic DNA programming. It suggests that woven into the fundamental fabric of reality is a kind of informational code, a cosmic genome that doesn't just describe the universe, but actively guides its evolution and development from the moment of its inception. Just as a single microscopic strand of biological DNA contains the elaborate instructions to build a complex, living organism, dictating everything from eye color to metabolic processes, this cosmic code could contain the instructions for building galaxies, stars, planetary systems, and even the potential for life. The laws of physics in this view are not merely passive rules that matter and energy must follow. They are the active, executing expressions of this primordial programming. Gravity, electromagnetism, and the nuclear forces are the tools this cosmic DNA uses to translate its information into physical form, sculpting the void into the magnificent structures we observe. This analogy helps us visualize how such a system could work. In an embryo, DNA doesn't contain a miniature picture of the adult organism. Instead, it holds a set of coded instructions that are activated in a specific sequence at specific times in response to its environment. This process guides the development from a single cell to a trillion-cell being. Similarly, a cosmic code wouldn't contain a pre-formed image of the Milky Way. It would contain the algorithms for gravitational attraction, the protocols for star formation through the collapse of gas clouds, and the parameters for supernova explosions that seed space with heavy elements. The universe unfolds according to this embedded plan, its evolution not random but directed, moving from a state of simplicity to ever greater complexity. The evidence for this might be seen in the eerie mathematical order that underpins all of nature. The consistent, non-random patterns of galaxy distribution throughout the cosmos resemble a growing neural network or a developing biological system following a set of underlying rules. Furthermore, the fact that the same fundamental constants and physical laws apply in the most distant galaxy as they do here on Earth suggests a unified source code running uniformly across the entire system. The emergence of life against unimaginable odds might not be a lucky fluke but an inevitable outcome once the conditions specified by this cosmic DNA are met, a built-in feature of the universe's programming, not a bug. This perspective offers a powerful answer to one of biology's greatest mysteries, the origin of life's own genetic code. How did non-living molecules arrange themselves into the exquisitely complex information system of DNA? The theory of cosmic DNA programming proposes a fascinating possibility, that life's code is a local expression, a physical instantiation, of the same type of informational architecture that built the cosmos. The universe didn't just create a suitable environment for life, it passed on its fundamental operating principle. In a very real sense, when we study the double helix, we might be looking at a microscopic echo of the universe's own blueprint, a biological testament to the encoded nature of all reality. But if our universe is a product of such intricate coding, a natural and profound question arises. Was this specific set of laws and constants the only possible outcome, or was it chosen? This leads us to our sixth theory, a concept that places our cosmic home within an almost unimaginably vast context: multiverse selection technology. Imagine not a single universe, but a limitless ocean of potential realities, each with its own unique physical laws and constants. In some, gravity might be repulsive; in others, atoms may never form. This is the multiverse, a predicted consequence of certain models of eternal inflation and string theory. Within this infinite cosmic landscape, our universe, with its perfect balance for life, seems like a statistical miracle. Multiverse selection technology proposes that this is no accident at all, that our universe was not a random draw from the cosmic lottery, but was deliberately identified and perhaps even actively engineered by a prior intelligence to meet specific criteria. This theory offers a powerful technological twist on the anthropic principle, which simply states that we observe a universe compatible with our existence because we couldn't exist in one that isn't. While that is a logical truism, it feels deeply unsatisfying as an explanation. Multiverse selection posits a mechanism. A civilization or entity existing outside of our space-time could possess the capability to scan this vast multiversal landscape using a form of cosmological natural selection. They wouldn't be creating universes from scratch, but rather searching through the infinite possibilities that naturally arise, looking for one with the right properties. The technology wouldn't be a universe creator, but the ultimate search engine, a reality filter designed to find a stable, fertile cosmos capable of fostering complexity and ultimately consciousness. How might such a selection process work? We can draw an analogy from our own world of machine learning and genetic algorithms. An AI isn't told the solution to a problem. It's given a goal and then runs through millions of iterations, selecting for the outcomes that get it closer to that goal. A multiverse selection technology could operate on a similar but infinitely grander scale, sifting through budding universes, selecting for those with longer lifespans, greater stability, or the potential for rich information processing. The goal might not have been us specifically, but a universe where something as complex as a biosphere or a self-aware mind could eventually emerge from the laws of physics. Our universe, in this view, is the winning candidate, the most fit version that was selected to survive and flourish. This idea also opens the door to an even more active form of engineering. Perhaps simply finding a suitable universe wasn't enough. The selecting intelligence might possess the ability to make precise, targeted adjustments to a universe's fundamental parameters after its initial selection, a form of cosmic tuning. The incomprehensibly precise values of the cosmological constant or the strength of the strong nuclear force might not just be the luck of the draw, but the result of post-selection calibration. This turns the multiverse from a random generator into a workshop, and our universe from a found object into a custom-built habitat. The echoes of this technology might be hidden in the very fine tuning that so perplexes physicists, not as evidence of a single creator, but as the fingerprints of a cosmic artisan who shaped a raw, nascent reality into the stable home we experience today. Yet if our universe was selected or tuned from a vast cosmic library, it begs the question of what medium could possibly support such an immense array of possibilities. This brings us to a seventh theory that proposes an answer so fundamental it redefines the nature of reality itself, a Planck scale computation. This idea suggests that the universe is not merely governed by physical laws, but is, at its absolute core, a vast and ongoing computation. And the hardware for this cosmic computer isn't made of silicon chips. It's the very fabric of space-time, operating at the smallest possible scale, the Planck length. To understand this, we need to venture down to the universe's ultimate resolution limit. The Planck length is an almost unimaginably tiny distance, about 1.6 times 10 to the negative 35 meters. That's so small that if you enlarged a single atom to the size of the observable universe, a Planck length would still be less than a meter across. At this scale, the smooth, continuous spacetime we experience shatters into a seething, frothing foam of quantum fluctuations. According to this theory, this isn't chaos, it's computation. Each fluctuation, each virtual particle popping in and out of existence, could be a fundamental processing event, a cosmic bit of logic being flipped. The universe isn't just like a computer, it literally is one, calculating its own state from one moment to the next. This view finds a powerful echo in the holographic principle, one of the most profound ideas in theoretical physics. It proposes that all the information describing everything within a three-dimensional volume of space, every star, every planet, every person, is actually encoded on a two-dimensional surface surrounding that volume, much like a hologram. Think of the security chip on your credit card, a flat, two-dimensional surface that, when illuminated with the right kind of light, projects a full three-dimensional image. The holographic principle suggests our reality is a projection, and the Planck scale is where that projection is processed. The information for the entire universe could be stored on its outer boundary, with every event within our 3D world being a manifestation of a computation happening on that distant 2D screen. The implications of this are staggering. The speed of light, the universe's ultimate speed limit, might not be a limit on motion, but on information processing, the maximum rate at which data can be transferred and computed from one Planck unit to the next. The famous uncertainty principle in quantum mechanics, which states that we cannot know both a particle's position and momentum with perfect accuracy, might not be a limitation of our measurement tools, but a fundamental feature of the system's architecture. It could be the cosmic equivalent of a processor's clock speed, setting a limit on how much information any region of space can contain and process at any given moment. If this is true, then everything we see and experience, from the flight of a bird to the orbit of a galaxy, is the magnificent output of an incomprehensibly vast and dense computation that has been running for 13.8 billion years. We are not just inhabitants of this universe, we are patterns emerging from its ongoing calculation, temporary manifestations of information being processed at the smallest scales of existence. The search for a fundamental theory of everything then becomes the search for the universe's operating system and the primal programming language in which it is written. This leads us to a theory that takes the most mysterious substance in the cosmos and reimagines it not as an inert component, but as an active technological artifact. This is the concept of dark matter technology. For decades, astronomers have known that something is wrong with our universe. Galaxies rotate at speeds that should fling their stars into the void, and massive clusters of galaxies bend light with a gravitational pull far greater than their visible matter can account for. The only explanation is that there is something else out there, a substance that does not emit, absorb, or reflect light, something we call dark matter. It makes up roughly 85% of all matter in the universe, yet we have no idea what it is. The prevailing view is that it's a type of unknown particle, a relic from the Big Bang. But what if it's something far more extraordinary? What if dark matter is the remnant or even the active component of a primordial technology? Consider its role. Dark matter acts as the invisible skeleton of the cosmos. It forms vast, diffuse halos around galaxies, providing the extra gravitational glue that holds them together. Without it, galaxies like our Milky Way would have never formed or would have long since torn themselves apart. This is a function so critical and so precise that it begs the question, is this a happy accident of nature, or could it be a form of cosmic engineering? The theory of dark matter technology proposes that this mysterious substance was deliberately deployed as a galactic scaffolding system. It's the framework upon which the visible universe was built, a technology designed to ensure the long-term stability of large-scale structures, creating the stable environments necessary for stars to form and planets to orbit for billions of years. But its purpose might extend far beyond simple scaffolding. If an intelligence could engineer a substance that interacts only through gravity, it would have created the perfect tool for gravitational control on a cosmic scale. Imagine being able to sculpt the gravitational landscape of the entire universe without ever being seen. This matter could be arranged in specific configurations to guide the flow of gas, to direct the collisions of galaxies, or to create gravitational lenses of immense power, perhaps even acting as a kind of interstellar communication network or focusing mechanism for energy. The fact that it doesn't interact with light makes it the ultimate stealth material, a technology that can shape the cosmos from the shadows without interfering with the delicate processes of chemistry and biology that happen within the light-based world. Perhaps the most intriguing possibility is that dark matter isn't just a structural material, but an energy source. We know it has mass, and where there is mass, there is potential energy. A sufficiently advanced technology might have found a way to tap into this energy, using it to power processes on a scale we can barely conceive. The mysterious filaments of dark matter that connect galaxy clusters across the vast voids of space could be seen not just as structures, but as a cosmic power grid, channeling energy from one region of the universe to another. This would be engineering on the grandest possible scale, a project that uses the very fabric of the cosmos itself as its infrastructure. The enduring mystery of dark matter, our inability to detect it through any means other than its gravity, might not be a failure of our science, but a testament to the exquisite design of a technology so advanced it is fundamentally invisible to the systems it was built to support. But if dark matter provides the cosmic scaffolding, what set that entire structure in motion? This brings us to one of the most pivotal moments in our universe's history, and a theory that proposes it was not a natural event, but the activation of a supremely sophisticated engine. We are, of course, talking about cosmic inflation, and Theory 9 posits it was a technologically induced process, a cosmic inflation drive. The Standard Model tells us that a fraction of a second after the Big Bang, the universe underwent a period of exponential expansion, inflating from smaller than a proton to roughly the size of a grapefruit in an incomprehensibly short window of time. This solved major cosmological puzzles, but it raises a profound question. What triggered this perfectly timed, perfectly calibrated burst of growth? The idea of a cosmic inflation drive suggests it was not a random quantum fluctuation, but the deliberate ignition of a universe-scale propulsion system. Think of it not as an explosion, but as the deployment of a stability mechanism. The initial state of the universe was incredibly hot, dense, and uniform. Without a mechanism to rapidly stretch space-time, that uniformity would have been a death sentence. Gravity would have immediately pulled everything back into a catastrophic collapse, a big crunch before anything could even form. The inflation drive solved this by expanding space itself at faster than the speed of light. It took that primordial uniformity and stretched it across a vast volume, effectively ironing out any dangerous wrinkles or over dense regions that could have led to a premature end. But it did more than just prevent collapse. It also implanted the seeds for all future structure. The microscopic quantum fluctuations that were present at that tiny scale were magnified to astronomical sizes during inflation, becoming the slight variations in density that would later, over billions of years, gravitationally coalesce into every galaxy, star, and planet we see today. This wasn't just expansion, it was a precise imprinting of cosmic blueprints. The technological brilliance of such a system lies in its exquisite fine-tuning. The drive didn't just turn on, it had to operate at an exact energy level and for a precise duration. If it had run for a minuscule fraction of a second longer, the universe would have been stretched into a cold, empty, and utterly barren void, with matter spread too thin to ever clump together. If it had shut off a moment too soon, the universe would have remained too small and too dense, collapsing back on itself almost immediately. The energy driving the inflation, often theorized by physicists as a hypothetical, inflaton field. had to have specific properties that allowed it to dominate the universe completely and then decay away perfectly, transferring its energy into the creation of the matter and radiation that fill the cosmos. From the perspective of this theory, the inflattened field wasn't a random field. It was the fuel for a designed engine, and its decay wasn't an accident but a controlled shutdown sequence. What evidence could point to this being a technology rather than a natural process? The signature is written across the entire sky. The cosmic microwave background radiation is a snapshot of the universe just 380,000 years after the Big Bang. Its stunning uniformity, with temperatures almost identical in every direction, is a direct prediction of inflation. It's the stretched-out result of that initial rapid expansion. Furthermore, the specific pattern of tiny temperature variations within that background radiation matches the predictions of quantum fluctuations being stretched by inflation with astonishing precision. It fits the model perfectly. The theory of a cosmic inflation drive asks us to consider that this perfect fit is not a happy coincidence of natural law, but the expected outcome of a successfully executed technological process. The drive did its job flawlessly, and the large-scale structure of the modern cosmos is the enduring testament to its operation. The universe we observe is not a chaotic accident, but the carefully expanded product of a mechanism that ensured its survival and fertility from the very first moment. Yet if the inflation drive provided the initial thrust, it raises the question of how a universe of such vast scale maintains coherence and connectivity. This brings us to a phenomenon so strange that even Albert Einstein famously described it as spooky action at a distance, quantum entanglement. Our 10th theory proposes that this isn't just a bizarre quantum quirk, but a sophisticated, built-in communication technology, a quantum entanglement network woven into the very substrate of reality. Imagine two particles born together or interacting in just the right way, becoming inextricably linked. Change the property of one, its spin, polarization, or momentum, and its partner, no matter if it's on the other side of the room or the other side of the galaxy, instantly reflects that change. This connection defies the cosmic speed limit of light, operating with a simultaneity that suggests a deeper layer of reality where distance is an illusion. The theory posits that this isn't a bug in the universe's programming. It's a feature, a primordial system for instantaneous information transfer engineered to operate on a cosmic scale. The technological elegance of such a system is breathtaking. In our own world, we struggle with the limitations of light speed. Sending a message to a star 1,000 light years away means a 2,000-year round trip for any reply. But an entanglement network would bypass this constraint entirely. It would allow for real-time coordination across the entire universe, a capability that would be essential for any project of cosmic proportions. Think of the large-scale structure of the cosmos, vast filaments of galaxies stretching across billions of light years, forming a complex web known as the cosmic net. How do such immense structures maintain their coherence? Perhaps the answer lies in a subtle, underlying quantum connectedness. A faint whisper of this network that helped guide the formation of the universe in its infancy, ensuring that widely separated regions could evolve in a synchronized fashion despite being beyond each other's light horizons. The purpose of such a network could extend far beyond mere structure. It might serve as the universe's operating system, a hidden layer where the fundamental constants and laws are continuously enforced and kept consistent. The fact that the speed of light or the charge of an electron is identical here and in the most distant galaxy we can observe is a profound mystery. An entanglement network could provide the mechanism for this consistency, a constant, instantaneous handshake between all particles ensuring the rules of the game remain the same everywhere. Furthermore, this could be the medium through which the cosmic code, the DNA of the universe we discussed earlier, is actually executed and expressed, with entangled particles acting as the nodes in a computational matrix of unimaginable scale and complexity. For us, now beginning to explore our own potential uses for quantum entanglement in quantum computing and cryptography, this cosmic network remains tantalizingly out of reach for practical communication. We can observe the correlation between entangled particles, but we cannot force a specific state upon one to send a predetermined message to its partner. The outcome of a quantum measurement is always random. This might seem like a design flaw, but it could very well be a built-in security protocol. A wide open entanglement channel across the universe could lead to chaotic interference, a cosmic crosstalk that would destabilize reality. The randomness acts as a firewall, allowing the universe to maintain its deeply connected state without being vulnerable to disruptive signals. Our inability to easily tap into this network for messaging might not be a limitation of our understanding, but a testament to the brilliant design of a system that keeps the fundamental architecture of reality secure and stable. This precise calibration of gravitational force is one of the most baffling and consequential features of our universe. If gravity were even a tiny fraction stronger, the consequences would be catastrophic. A star's core would burn through its nuclear fuel at an exponentially faster rate, causing stars to flare into existence and burn out in a cosmic blink, leaving no time for planets to form, let alone for life to evolve. An Earth-like planet would need to be significantly smaller to have a surface gravity we could withstand, but a smaller planet would lose its atmosphere and internal heat too quickly, becoming a cold, airless rock. Conversely, if gravity were slightly weaker, the universe would be a far more lethargic and sterile place. The initial gravitational collapse of gas clouds that birth stars might never overcome the gas's internal pressure, leaving the cosmos a dark, starless haze of hydrogen and helium. Planets might never coalesce properly, and any that did would have such weak gravity they couldn't hold onto an atmosphere. The force that holds our feet to the ground is the same force that orchestrates the grand ballet of galaxies, and its value seems impossibly perfect for creating a universe that is both structurally rich and long-lived enough for complexity to arise. This fine-tuning extends beyond simple star formation into the very architecture of solar systems. Our own solar system is a testament to gravity's precise engineering. The Sun's gravity holds the system together, while the planet's orbital distances and velocities create a stable, resonant structure that has persisted for billions of years. The gravitational interplay between a star and its planets helps drive internal geological activity. For a world like Earth, this means a molten core that generates a protective magnetic field and tectonic activity that recycles minerals and regulates our climate. This isn't just about holding things together, it's about creating dynamic, interactive systems. The Moon's gravity, for instance, stabilizes Earth's axial tilt, preventing wild climate swings that would make complex life impossible. Jupiter's immense gravity acts as a cosmic vacuum cleaner, its gravitational well deflecting or capturing comets and asteroids that might otherwise bombard the inner planets with sterilizing impact. From this perspective, gravity acts less like a simple force and more like a master regulatory system, a technology that doesn't just create structure but actively maintains and protects it over astronomical timescales. The theory of gravitational engineering proposes that this isn't a series of fortunate accidents, but the result of a deliberate setting. The strength of gravity is determined by the gravitational constant, a fundamental number in physics known as Big G. In a universe of random chance, finding a value that allows for galaxies, stars, planets, and biochemistry seems astronomically unlikely. This technology would have involved the ability to set this constant with unimaginable precision during the universe's formative moments. It's akin to a master engineer adjusting a dial on a cosmic control panel, selecting the exact value that would yield the most stable and fertile universe possible. The goal may not have been humanity specifically, but a cosmos capable of fostering any form of complex, enduring order. Gravity's perfect weakness is its greatest strength. It is strong enough to sculpt the cosmos, but weak enough to allow for the delicate electromagnetic and nuclear forces to build atoms, molecules, and ultimately life without being immediately crushed. This delicate balance is the hallmark of a system that was designed for purpose, not one that emerged from chaos. Now, if gravity's precise calibration suggests a master engineer at work, then perhaps the ultimate signature of that craftsman is waiting for us, etched across the entire sky in the faintest whisper of heat. This is the theory of a cosmic microwave background code. The CMB is the oldest light in the universe, the cooled remnant of the Big Bang's fiery birth, and it surrounds us in every direction. To cosmologists, it is a treasure trove of data, a baby picture of the cosmos. But what if it is more than just a thermal echo? What if this ancient radiation is the universe's original hard drive, imprinted with a message, a blueprint, or the signature of the technologies that set everything in motion? The concept hinges on the incredible uniformity and subtle pattern of the CMB. This radiation is almost perfectly smooth, but not quite. It contains tiny anisotropies, minute variations in temperature on the order of 1 part in 100,000. These fluctuations are the seeds from which all cosmic structure grew. The slightly hotter, denser spots eventually collapsed under gravity to form galaxies and clusters. But from the perspective of this theory, these patterns might hold a dual purpose. The specific arrangement of these hot and cold spots could be a form of information encoding. Just as a barcode uses a sequence of black and white lines to store data, the pattern of temperature variations in the CMB could represent a message written on the largest possible canvas. How could such a thing be achieved? The mechanism would be astonishingly sophisticated. The theory suggests that the initial quantum fluctuations, the microscopic wrinkles in space-time that were magnified by the inflation drive, were not random. They were carefully crafted. A prior intelligence could have engineered the inflatoned field, the energy source of inflation, to produce a very specific spectrum of fluctuations. As inflation stretched these quantum imprints to cosmic sizes, it would have effectively written a message across the entire sky, a message that would become frozen in place as the universe cooled and the CMB was released. The technology required to do this is unimaginable. It would involve controlling quantum processes at the universe's very inception to precisely dictate the pattern of temperature variations that would appear billions of years later. The search for such a code is not pure speculation. Scientists have already scoured the CMB data for anomalous patterns that defy standard cosmological predictions. Some researchers have looked for signs of non-randomness, like concentric circles that could suggest our universe was shaped by collisions with other universes in the multiverse. Others have searched for evidence of a preferred direction or axis in the universe, sometimes called the axis of evil, which could hint at a fundamental asymmetry imprinted at creation. While most of these anomalies have plausible physical explanations or are within the bounds of statistical noise, the mere act of looking is telling. We are instinctively searching the cosmos for a signature, for a sign that we are part of something designed. If a message is there, what form would it take? It likely wouldn't be a simple hello written in English. It would be a message of a far more profound nature. It could be a fundamental mathematical constant, like pi or the fine structure constant, encoded in the pattern of hot and cold spots to confirm the universe's engineered nature. It could be a blueprint for the standard model of particle physics, a kind of cosmic cheat sheet left behind for any intelligent species advanced enough to decode it. Or it could be a signature, a unique identifier for the architects or the technology they used, a copyright stamp on reality itself. The message might not even be for us. It could be a beacon or a set of instructions for other technologies or intelligences operating on a cosmic scale, with the CMB serving as a permanent, universal billboard. Decoding such a message would be the ultimate scientific and philosophical endeavor. it would require us to move beyond simply mapping the CMB's power spectrum and to analyze its patterns with the tools of cryptography and information theory. We would be looking for a signal within the noise that exhibits a level of complexity or specificity that natural processes could not produce. Finding it would be the most monumental discovery in human history, transforming our understanding of reality from a cosmos of chance to a cosmos of intent. The faint afterglow of creation would become our most direct line to the source, a 13.8 billion-year-old message waiting in the static of deep space for a civilization wise enough to finally read it. Yet, for all its apparent emptiness, this quantum vacuum is not truly empty at all. According to quantum field theory, every point in space is a seething, bubbling cauldron of activity. Particle-antiparticle pairs constantly flicker into and out of existence, borrowing energy from the vacuum itself for unimaginably short periods of time before annihilating and returning it. This isn't just theoretical. We can observe the effects of this vacuum energy in the lab, most famously in the Casimir effect, where two uncharged metal plates placed incredibly close together in a vacuum are gently pushed together by the pressure of these virtual particles popping into existence outside them. The space between the plates restricts the types of fluctuations that can occur, creating a subtle force that demonstrates the vacuum is very much alive with potential energy. This omnipresent background hum of the universe is known as zero-point energy, a limitless and foundational energy source that exists even at absolute zero temperature. Theory 13, vacuum energy technology, proposes that this is not a mere curiosity of quantum mechanics, but a deliberate feature, a built-in universal power grid engineered by a primordial intelligence. The quantum vacuum, in this view, is not a passive stage upon which the drama of the universe plays out. It is an active participant, a sophisticated energy technology designed to fuel cosmic processes from the smallest scale to the largest. The ability to harness the energy of the vacuum itself would represent the apex of technological achievement, a mastery over the most fundamental layer of reality. A civilization that could tap into this source would have access to literally limitless power, enabling projects of a scale we can scarcely imagine, from stabilizing entire galaxies to perhaps even influencing the very expansion rate of the universe itself. This theory offers a radical reinterpretation of one of the greatest mysteries in modern cosmology, dark energy. We've observed that the expansion of the universe is not slowing down due to gravity, but is instead accelerating. Something is exerting a repulsive force, pushing galaxies apart at an ever-increasing rate. The leading candidate for this mysterious force is the energy inherent in the vacuum of space itself. Physicists calculate what this vacuum energy should be based on quantum theory, but there's a catastrophic problem. The predicted value is a staggering 120 orders of magnitude. That's a 1 with 120 zeros after it, larger than what we actually observe. This is the largest discrepancy between theory and observation in all of science. The vacuum energy technology theory proposes a stunning resolution. This value isn't a miscalculation or a natural constant. It is a carefully set, deliberately tuned parameter. The vacuum energy was engineered to be precisely what it is, not too strong to rip apart atoms before they could form, and not too weak to allow gravity to collapse the universe too soon. It is a dial on the cosmic control panel that was set to an exact value to ensure the universe would have a long, fertile, and structurally rich lifespan. The implications of this are profound. The vacuum would be the ultimate battery, a distributed energy source that permeates all of space and time. This technology wouldn't require wires or power plants. It would be built into the fabric of existence itself. The initial ignition of the cosmic inflation drive could have been powered by a targeted extraction of vacuum energy, a controlled tapping of this primordial reserve to launch the expansion of spacetime. Furthermore, the consistent and uniform nature of dark energy's effect across the entire observable universe suggests it is a property of space itself, not something localized. This fits perfectly with the idea of an engineered vacuum, a uniformly configured energy field that was set once at the beginning and has been passively powering the cosmos ever since. The acceleration of the universe isn't a sign of its impending death and isolation, but could be the expected long-term operation of this technology, ensuring the cosmos continues to expand and create new space, perhaps as part of a grand, unfathomable cycle. We are not just living in a universe with vacuum energy. We are living inside a technology that is, at this very moment, powering the cosmos. This perspective invites us to consider biological evolution not as a process unique to our planet, but as a fundamental cosmic principle. Just as life on Earth has advanced from simple single-celled organisms to the incredible complexity of the human brain, the universe itself has evolved from a hot, featureless soup of particles into the intricate web of galaxies, stars, and planetary systems we observe today. This isn't merely a poetic comparison. It suggests a deep, underlying pattern where complexity emerges through a process of selection, adaptation, and replication on a cosmic scale. Stars forge heavy elements in their cores and scatter them across space in supernova explosions, effectively seeding the cosmos with the raw materials for planets and, ultimately, life. Galaxies collide and merge, creating new structures in a process that mirrors the symbiotic relationships and horizontal gene transfer seen in biology. The entire cosmos appears to be following a kind of developmental blueprint, moving from simplicity to ever greater complexity and organization, guided by an inherent drive that looks remarkably like a biological imperative. At the heart of this theory lies the radical idea that information systems akin to DNA might operate on a universal scale. We know that biological DNA is more than just a blueprint. It's an active information processing system that directs growth, responds to environmental cues, and guides development. The biological universe theory proposes that a similar, though far more fundamental, informational code is embedded within the laws of physics themselves. This cosmic genome wouldn't be written in the base pairs of adenine, thymine, guanine, and cytosine, but in the language of mathematics and quantum states. The fundamental constants, the gravitational constant, the speed of light, the strength of the electromagnetic force, are not arbitrary numbers but the expressed parameters of this code. They act as the regulatory genes of the cosmos, determining how reality will unfold. The laws of physics, in this view, are the executing software, translating this cosmic genetic information into the physical structures we see, from the spin of an electron to the grand rotation of a galaxy. We might even find evidence for this in the very structure of the cosmos. The large-scale distribution of galaxies isn't random. It forms a complex, web-like structure of filaments, nodes, and voids that bears a stunning resemblance to a neural network or a mycelial network. This cosmic web could be seen as the growing, developing structure of the universe, a physical manifestation of its underlying informational code. Furthermore, the emergence of life from non-living matter, a transition that remains one of science's greatest mysteries, might be reinterpreted not as a miraculous accident but as an inevitable phase transition. Once the local conditions on a planet meet the requirements specified by the cosmic code, the right elements, the right energy sources, the right stability, the emergence of a localized biological system becomes a foregone conclusion, a natural expression of the universe's inherent biological nature. In this light, life is not a separate phenomenon from the cosmos. It is the cosmos becoming conscious of itself, a flowering of the biological potential that was written into its fabric from the very first moment. But if the universe itself possesses a biological or informational nature, it compels us to confront one of the most enduring and profound mysteries of all, the nature of consciousness itself. This leads us to a theory so radical it inverts our entire understanding of existence: consciousness integration technology. For centuries, the prevailing scientific view has treated consciousness as an emergent property, a fascinating but secondary byproduct of complex computational processes occurring within the wetware of our brains. It's the ghost in the machine, the software that somehow boots up when the neural hardware reaches a sufficient level of complexity. But this perspective, often called emergentism, faces a formidable challenge known as the hard problem of consciousness, articulated by philosopher David Chalmers. It's the question of why and how any physical process, no matter how intricate, should give rise to subjective, inner experience at all. Why do we not merely process information like sophisticated robots, but actually feel the warmth of the sun, the taste of chocolate, the sting of loss? Consciousness integration technology proposes a breathtaking answer because it was designed to. This theory posits that consciousness is not an emergent epiphenomenon, but a fundamental, primary feature of the cosmos, woven directly into the fabric of space-time by a primordial technology. Consider the implications of this shift. Instead of the brain generating consciousness like a generator producing electricity, the brain might instead be a highly sophisticated receiver, filter, or transducer for a consciousness field that already permeates all of reality. This view, known broadly as panpsychism in philosophy, suggests that some form of proto-consciousness or experience is a basic property of matter, much like mass or charge. Consciousness integration technology takes this a step further, suggesting this wasn't a random feature of matter, but a deliberately engineered one. The technology would have involved setting the fundamental parameters of quantum mechanics to allow for the coupling between physical states and subjective experience. In this model, the intricate neural networks of a brain don't create consciousness from nothing. They provide the complex structure necessary to receive, focus, and interpret this universal field into the rich, detailed tapestry of our individual minds. This perspective offers elegant solutions to several puzzles. The binding problem, which questions how the brain seamlessly integrates millions of disparate sensory inputs into a single, unified conscious experience, becomes less mysterious if consciousness is already a unified field that the brain simply taps into. Furthermore, it provides a framework for understanding bizarre quantum experiments like the double-slit experiment, where the act of observation seems to affect the outcome. If consciousness is a fundamental component of reality, not just a passive observer, then its interaction with the quantum realm makes a new kind of sense. The universe wasn't just built to be stable and fertile, it was built to be experienced. The entire cosmic architecture, from the formation of stars to the evolution of life, could be seen as a grand process of creating increasingly sophisticated instruments, brains, for the universe to know and experience itself. Our subjective inner lives are not a glitch in a vast, meaningless machine. They are the entire point of the machine's operation. The implications for the nature of existence are nothing short of revolutionary. If consciousness is a built-in technology, then reality is not a cold, objective collection of atoms governed by mindless laws. It is inherently experiential. This suggests that the relationship between the observer and the observed is far more intimate than we ever imagined. We are not separate from the universe looking in. We are the universe looking out at itself. The search for extraterrestrial intelligence then transforms. We wouldn't just be listening for radio signals. We'd be seeking other nodes of complex consciousness, other manifestations of this universal capacity for experience. It also radically reframes the so-called fine-tuning of the universe. The constants aren't just right for life, they are precisely calibrated for conscious life. They allow for the development of the complex, information-rich structures necessary to manifest this fundamental property in its most vivid and profound forms. In the end, consciousness integration technology doesn't just explain how we came to be. It suggests that our capacity to wonder, to feel, and to ask these very questions is the most sophisticated and intended output of the universe's first and most essential technology. But what if the universe's grandest structures are not just the result of natural forces, but the literal scaffolding left behind by its construction? This brings us to the incredibly dense and mind-bending concept of cosmic string technology. In the quest to understand the universe's origins, physicists have theorized the existence of bizarre one-dimensional defects in the fabric of spacetime itself, known as cosmic strings. These are not strings in any ordinary sense. Think of them as unimaginably thin, incredibly dense cracks or wrinkles in reality that formed during the universe's earliest, most extreme phase transitions as the fundamental forces froze into their current separate identities. Most theories treat these objects as fascinating theoretical relics, but our 16th theory proposes they are something far more significant: the active remnants or even the still operational components of the technologies that built our cosmos. The scale and power of a cosmic string is almost beyond comprehension. A single string might be narrower than a proton, yet a mere inch of it could contain more mass than Mount Everest. They would stretch across the universe for billions of light years, vibrating and moving at relativistic speeds. Their gravitational influence would be so intense that they could act as gravitational lenses, warping the light from galaxies behind them. And if one were to pass through our solar system, it would create detectable ripples in spacetime. But from the perspective of cosmic string technology, these aren't just random flaws. They are the girders and power lines of cosmic scale engineering. A sufficiently advanced intelligence could have intentionally created these structures during the universe's formation to serve as a permanent framework, a skeleton upon which the visible matter of galaxies and galaxy clusters would later be draped. The vast filamentary web of the cosmic net, with galaxies strung along like pearls on a necklace, might not be a random gravitational outcome, but a direct result of the universe forming along these pre-established technological lines. Their potential utility extends far beyond mere structure. A cosmic string, with its immense density and energy, could be the ultimate energy source or transmission line. The theory suggests they might function as a cosmic scale power grid, channeling energy from one region of the universe to another. The vibrations and oscillations along a string's length could carry information, making it a superluminal communication network, allowing for coordination across distances that would otherwise be isolated by the vastness of space and the limiting speed of light. The technology required to create or harness such an object is unimaginable, involving the ability to manipulate the very symmetries of the universe and tie knots in spacetime itself. If such strings exist, they would be the most durable and permanent structures in existence, outliving even stars and galaxies, a permanent testament to the engineering that occurred at the dawn of time. The search for evidence of cosmic strings is an active frontier in cosmology. Astronomers scan the cosmic microwave background for their unique signatures: tiny, telltale jumps in temperature or specific patterns of polarization that a moving string would imprint on the ancient light. They also look for double images of distant galaxies or quasars, lined up perfectly, which could be caused by the extreme gravitational lensing of an invisible string cutting across our line of sight. While no definitive proof has been found yet, the hunt continues. Finding a cosmic string would be a monumental discovery for physics. But if that string also exhibited signs of non-random structure, perhaps a precise, repeating pattern in its gravitational effects, it could be the first tangible piece of evidence that we are not just looking at a fossil of the early universe, but at a piece of its construction equipment still hanging in the depths of space, a silent remnant of the universe's first and greatest technologies. But what if even the most fundamental building blocks of reality, the quantum fields that give rise to every particle and force, are not simply features of the universe, but its most sophisticated technology? This brings us to our 17th theory, an idea that goes to the very heart of modern physics, quantum field engineering. In our current understanding, the universe isn't primarily made of solid matter. Instead, it's a vast ocean of invisible, omnipresent fields. The electromagnetic field, the electron field, the quark fields, these are not just abstract concepts. Physicists believe they are the true bedrock of reality. Particles are not little balls, they are localized excitations, tiny vibrations in their respective fields, like waves rising from the surface of the sea. An electron is simply a place where the electron field has been plucked, a knot of energy in that specific field. This framework, known as quantum field theory, is one of the most successful in all of science, making predictions with astonishing accuracy. The theory of quantum field engineering takes this a step further, proposing that these fields themselves and their specific properties were not random outcomes of the Big Bang, but were meticulously designed and calibrated. The evidence for this lies in the exquisite precision of the field's parameters. Each quantum field has a set of properties that dictate how its corresponding particles behave. The mass of a particle is determined by its interaction with the Higgs field. The charge of an electron is a fixed value within the electromagnetic field. The strength of the forces between particles is set by coupling constants, fundamental numbers that act like dials controlling the intensity of each interaction. The theory posits that these values were not left to chance. They were precisely chosen to create a stable, interactive, and complex universe. If the mass of the quark fields were slightly different, protons might not form, and without protons, there would be no atomic nuclei. If the coupling constant for the strong nuclear force were even a fraction weaker, atomic nuclei would fly apart. If it were stronger, all the hydrogen in the early universe would have fused into heavier elements, leaving no fuel for stars. The fields are not just there, they are perfectly tuned to allow for the existence of everything we see. This technological perspective offers a new way to interpret one of physics' greatest tools, the Standard Model. This model is essentially a catalog of the known quantum fields and the rules for their interaction. Its equations are incredibly precise, but they also contain over 20 free parameters, numbers like particle masses and force strengths that we must measure experimentally because the theory cannot predict them. From the viewpoint of quantum field engineering, these aren't embarrassing holes in our knowledge. They are the architectural specifications of the technology. They are the dials that were set by the engineers. The fact that the Standard Model works so perfectly with these inserted values, but provides no reason for the values themselves, could be seen as a signature of a designed system. The model describes the operating software of the universe, but the initial settings were input by a programmer. The implications of this theory extend into the deepest mysteries of the cosmos. The fact that there are multiple fields, each with its own role, suggests a modular design. The electromagnetic field handles light and chemistry, the gravitational field shapes the large-scale structure, and the gluon field binds atomic nuclei together. This isn't a single, monolithic force, but a suite of specialized tools, each perfectly crafted for its specific task. This kind of specialized, interoperable design is a hallmark of sophisticated engineering, not random chance. Furthermore, the process of symmetry breaking that occurred in the early universe, which gave each field its distinct properties, could be reinterpreted not as a random cooling, but as the deliberate execution of a technological sequence, a boot-up process where the core functions of reality were initialized and brought online. In this light, the quantum fields are the universe's most fundamental and enduring technology, the active framework that continuously generates reality moment by moment, according to a set of brilliantly engineered rules. Building on the idea of quantum fields as a designed framework, we arrive at one of the most enigmatic and powerful features of our universe, the black hole. Conventionally, these are seen as terrifying regions of spacetime where gravity is so intense that nothing, not even light, can escape. But our 18th theory, black hole technology, proposes a radical shift in perspective. What if these cosmic behemoths are not merely destructive ends, but sophisticated technological devices serving critical functions within a larger cosmic architecture? Rather than being simple graves for stars, they could be quantum computers, information repositories, or even gateways engineered for a purpose far beyond our current understanding. One of the most compelling roles for a black hole in this technological framework is that of a quantum computer of unimaginable scale. The extreme conditions within and around a black hole are a natural playground for quantum mechanics and gravity to interact. The event horizon, the point of no return, could act as a natural information processing surface. Theoretical work by physicists like Leonard Susskind has led to the holographic principle, which suggests that all the information describing everything that falls into a black hole is not lost, but is encoded on its two-dimensional event horizon. This is akin to a cosmic hard drive, storing information at the theoretical maximum density allowed by physics. A technology capable of harnessing this process could use a black hole to perform computations of staggering complexity. The natural tendency of a black hole to thermalize and scramble information could be a built-in feature for executing specific types of algorithms, solving problems that would take conventional computers longer than the age of the universe to complete. This leads directly to the second function, information storage. The black hole information paradox has long puzzled physicists, questioning what happens to the information contained in matter that crosses the event horizon. If black holes eventually evaporate over eons via Hawking radiation, does that information vanish, violating a fundamental tenet of quantum mechanics? The technological perspective offers a fascinating solution. The information isn't lost, it's permanently archived. A black hole could be the universe's ultimate library, a secure and immutable data vault. The incredible stability and longevity of supermassive black holes, which can live for trillions of years, make them perfect for this role. They could be storing the cosmic history of the galaxies they anchor, a complete record of every star, planet, and event that has ever been consumed. For a civilization that understands how to decode Hawking radiation, retrieving this information might be possible, allowing them to read the history of the cosmos from these dark, silent sentinels. Perhaps the most speculative yet captivating idea is that black holes function as gateways or transit systems within a multiverse. The singularity at a black hole's heart, where density becomes infinite and our known laws of physics break down, might not be an end but a transition point. Theoretical models like the Einstein-Rosen bridge, popularly known as a wormhole, suggest a black hole singularity could connect to a white hole in another region of space-time or even in another universe entirely. While naturally occurring wormholes are thought to be unstable and collapse instantly, a technology capable of manipulating space-time on this scale could stabilize such a passage. A black hole could be the cosmic equivalent of a subway station, a controlled entry point into a network of interconnected realities. The immense gravitational forces would be part of the technology's operation, powering and maintaining the stability of the gateway for transit. The placement of these objects adds weight to this technological hypothesis. Nearly every large galaxy, including our own Milky Way, is now believed to harbor a supermassive black hole at its very center. This is not a random distribution, it appears to be a universal rule. From an engineering standpoint, locating a critical piece of infrastructure at the gravitational center of a galaxy makes perfect sense. It provides a stable anchor point, and its immense gravity would naturally help structure and shape the entire galaxy swirling around it. These central black holes could be regulating galactic evolution, controlling the rate of star formation, and perhaps even managing energy flows across vast distances. Their consistent presence at the heart of cosmic cities suggests a functional role far greater than that of a simple celestial vacuum cleaner. evidence for this extraordinary idea might be found in the behavior of matter just before it falls in. The accretion disks of superheated plasma that swirl around active black holes are among the most energetic phenomena in the universe, blazing with light across the entire spectrum. We often see colossal jets of material being shot out from the poles of these black holes at nearly the speed of light, stretching for thousands of light years. This could be seen as mere wasted energy, but from a technological viewpoint, it might resemble the exhaust plume or the operational byproduct of an immense engine. The precise mechanisms that form these jets are still not fully understood, and their incredible power and directionality could hint at a process that is more engineered than purely natural. The black hole is not just consuming, it is also expelling energy in a focused, purposeful way, influencing its environment on a galactic scale, and perhaps even contributing to the cycle of matter and energy that fuels the birth of new stars and planets in its galaxy. Yet if black holes are potential engines or gateways, their operation would be governed by the universe's most famous and inflexible rule, the speed of light. This brings us to our 19th theory, an idea that reinterprets this cosmic constant not as a simple law of nature, but as a deliberately set piece of technology, light speed limit technology. We all learn that nothing can travel faster than light in a vacuum, a universal speed limit of about 299,792,458 meters per second. But why this specific number? Physics tells us it's derived from other fundamental constants, but that just pushes the question back a step. Why do those constants have the values they do, resulting in this particular speed? This theory proposes that the value of the speed of light, denoted as c, is not a random outcome but an engineered constraint, a built-in regulator that shapes everything from causality and communication to the very structure of spacetime itself. Consider the profound implications of this speed limit. It is the ultimate arbiter of cause and effect. Because information cannot travel faster than light, it enforces a strict cosmic order where an event here can only influence an event over there after enough time has passed for light to bridge the gap. This creates what physicists call a light cone, a boundary that defines the possible past that could have influenced you and the possible future you can affect. This isn't just a limitation, it's the foundation of a stable, paradox-free universe. Without this speed limit, the principle of causality would break down. Effects could precede their causes, leading to logical impossibilities that would make a coherent, predictable reality impossible. From this perspective, the speed of light isn't a barrier to be overcome. It's a cornerstone of cosmic architecture, a technological solution to the problem of chaos, ensuring that the universe operates in an orderly, sequential fashion. This constraint also has a defining effect on the nature of communication and community across the cosmos. The vast distances between stars and galaxies are not just spatial, they are temporal. Sending a message to a star 100 light-years away means a 200-year round trip for any reply. This effectively isolates civilizations, ensuring that no single intelligence can project power or coordinate actions across the entire galaxy in a short time frame. This galactic quarantine, enforced by the speed of light, could be a designed feature to allow life and intelligence to evolve independently, free from immediate interference or domination by older, more advanced species. It creates a universe of islands, fostering unique evolutionary paths and preventing the rapid spread of potentially destructive ideologies or technologies. The speed of light acts as a cosmic pacing mechanism, forcing a slow, deliberate progression and encouraging local development and self-reliance. Furthermore, this limit is deeply woven into the fabric of spacetime itself, as revealed by Einstein's theory of relativity. The famous equation E equals mc squared shows that the speed of light is the conversion factor between matter and energy. This isn't just a formula, it's a statement about the fundamental cost of existence. The incredibly large value of c² is why a tiny amount of matter can release a colossal amount of energy, as in a nuclear reaction. This value was set to allow for the intense energy production that powers stars for billions of years, providing the stable environments necessary for life to evolve on orbiting planets. If the speed of light were significantly slower, the energy output of stars would be feeble, and the universe would be dark and cold. If it were faster, stars might burn too fiercely and too briefly. The specific value of c is therefore integral to creating a long-lived, energy-rich universe capable of fostering complexity. The technological signature might also be found in the unique behavior of light itself. Photons, the particles of light, are massless. They are the only particles that can actually travel at the maximum speed limit. This is not an accident. A massless messenger is the perfect medium for transmitting information without distortion or delay within the constraints of the system. The fact that all observers, regardless of their own motion, will always measure the same speed for light is another deeply strange and non-intuitive feature. This principle of invariance ensures that the laws of physics are the same for everyone, creating a universal and consistent reality for all observers. This consistency is exactly what you would expect from a well-designed system, where the core rules are hardwired to be reliable and unchanging. The speed of light is less a law we discovered and more a universal constant that was implemented to guarantee the stability and coherence of the entire cosmic experiment. This profound imbalance between matter and antimatter is one of the universe's most critical and mysterious features. For every billion pairs of matter and antimatter particles that should have annihilated each other in the early universe's immense heat, a single matter particle survived. That tiny 1 in a billion asymmetry is the reason you, me, and everything we see exists at all. Without it, the universe would be nothing but a fading bath of light, utterly empty of stars, planets, or people. The conventional explanation points to a necessary violation of fundamental symmetries, a process known as baryogenesis. But what if this wasn't a fortunate statistical fluke? What if this critical tipping of the scales was a deliberate, engineered event, a masterstroke of cosmic symmetry-breaking technology? To understand this, we must first appreciate what symmetry means in physics. It doesn't refer to visual balance, but to an underlying sameness or invariance under transformation. In the unimaginably hot, dense first moments after the Big Bang, the universe is thought to have been in a state of perfect symmetry. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were unified into a single superforce. Matter and antimatter were in perfect balance. There was no distinction between particles like electrons and quarks. They were all part of a unified, symmetric whole. As the universe expanded and cooled, it underwent a series of phase transitions, much like steam condensing into water or water freezing into ice. With each drop in temperature, a symmetry was spontaneously broken. The superforce splintered into the distinct forces we know today, and the primordial soup of particles acquired their unique identities. The critical question is, were these breaks truly spontaneous and random, or were they technologically guided to produce a specific, life-allowing outcome? The theory of guided symmetry breaking suggests the latter. It posits that the parameters controlling these phase transitions were not left to chance. A prior intelligence could have engineered the specific conditions, the equivalent of carefully controlling the temperature and pressure, to ensure the universe cooled in exactly the right way. The most crucial break was the one that led to the matter-antimatter asymmetry. This required a violation of three specific conditions outlined by physicist Andrei Sakharov, a process that treated matter and antimatter differently. CP violation, a departure from thermal equilibrium, and an interaction that could change the total number of baryonic particles. Finding natural processes that satisfy all three conditions has been a monumental challenge for physics. The technological perspective offers a stunning resolution. These weren't rare natural phenomena, they were built-in features of the breaking mechanism. The how of baryogenesis was encoded into the universe's initial programming, a guaranteed outcome of its controlled cooling process. The evidence for this guided break might be found in the incredible precision of the outcome. The degree of asymmetry had to be exquisitely fine-tuned. If the imbalance had been significantly larger, say 1 part in a million instead of a billion, the excess matter would have led to a universe far denser than our own. Gravity would have caused it to collapse back on itself in a big crunch long before any stars could form. If the asymmetry had been smaller, there might not have been enough matter left over to form even a single galaxy. The observed value is once again Goldilocks perfect. Furthermore, the breaking of the electroweak symmetry, which gave mass to the W and Z bosons while leaving the photon massless, was equally precise. This is the reason we have a long-range electromagnetic force capable of holding atoms together and a short-range weak force responsible for nuclear fusion in stars. The specific values of the particle masses that emerged from this breaking are not random. They are the exact values needed for carbon-based life and a stable, long-lived cosmos. This consistent, life-permitting precision across multiple independent symmetry breaks points toward a coordinated design rather than a series of lucky accidents. This theory also provides a fascinating new interpretation for the Higgs field, the cosmic molasses that gives particles their mass through the Brout-Englert-Higgs mechanism. The Higgs is the direct result of electroweak symmetry breaking. Its specific properties, the shape of its potential energy field, determine the masses of fundamental particles. From the viewpoint of cosmic symmetry breaking technology, the Higgs field is less a spontaneous occurrence and more a calibrated instrument. It was set to specific vibrational frequencies that would endow electrons, quarks, and other particles with their precise masses. The fact that the Higgs boson was discovered at the Large Hadron Collider with almost exactly the mass predicted by the Standard Model isn't just a victory for science. It could be seen as us reverse engineering a piece of the universe's core technology, confirming the settings of a dial that was carefully turned at the dawn of time. The symmetries were not simply broken. They were expertly fractured along predetermined fault lines to construct the diverse, interactive, and life-friendly reality we inhabit. At the quantum level, reality is a shimmering haze of probability, a place where particles can exist in multiple states at once and be intimately connected across vast distances. Yet we live in a world of definite objects and concrete events. The chair you're sitting on doesn't exist in a blur of possible locations, it's right there. This transition from the fuzzy quantum world to the sharp classical one is governed by a process called decoherence. But what if this isn't just a passive, inevitable law of physics? Theory 21 proposes that quantum decoherence control is a sophisticated technology, a carefully engineered system designed to collapse quantum possibilities into a single, stable, shared reality for all of us to experience. To grasp this, imagine a perfectly still pond. Tossing a single pebble creates a clean set of ripples. This is akin to an isolated quantum system, like a single electron, existing in a pure state of multiple possibilities, known as superposition. Now imagine that same pond during a rainstorm. The surface is churned by countless droplets, and the clean ripples from your pebble are instantly lost in the chaotic patter. This is decoherence. In our universe, the rainstorm is the constant, unavoidable interaction of quantum systems with their environment, bombardment by photons, collisions with air molecules, the subtle pull of gravity from distant stars. These interactions aren't dramatic, they are ceaseless and microscopic, but their cumulative effect is to force quantum systems to choose a definite state, to collapse from a wave of probability into a particle with a specific location. This theory suggests that the rate, the mechanism, and even the very nature of this process were not left to chance. They were calibrated technologies. The brilliance of this engineering lies in its perfect balance. If decoherence happened too easily or too quickly, the quantum world would never manifest its bizarre and essential properties. Quantum tunneling, which allows protons to fuse together at the core of stars, would be impossible. The strange coherence of photosynthesis, which allows plants to transfer energy with near-perfect efficiency, might not occur. Our sun wouldn't shine, and life might not have found an energy source. Conversely, if decoherence were too weak or too slow, the macroscopic world would be a blurry, unstable mess. Atoms would struggle to form stable bonds, molecules wouldn't hold their shape, and chairs really might flicker in and out of existence. The fact that we have a clear division, a quantum realm that operates by its rules underneath a classical world that operates by ours, is a feature, not a bug. It's a designed separation of powers that allows for both the stability needed for planets and people and the quantum weirdness needed for stars and semiconductors. This controlled collapse might also be the ultimate mechanism for enforcing a single, objective reality. One of the deepest puzzles of quantum mechanics is the measurement problem. Why does observing a system force it into one state? The technological perspective reframes this. The observer isn't necessarily a conscious being. It's the environment itself acting as a continuous measurement device. This process ensures that you and I see the same moon in the same part of the sky. It prevents different versions of reality from branching off or conflicting with each other. The technology of decoherence creates a consensus reality, a shared experience that is consistent for every observer within it. It's the universe's own error correction protocol, constantly resolving quantum uncertainties into classical certainties to maintain a stable, coherent world. Evidence for this design process might be found in its incredible robustness and uniformity. Decoherence happens in exactly the same way, following the same mathematical rules, here on Earth as it does in the vacuum of intergalactic space and as it did 13.8 billion years ago. This consistency is what allows the laws of physics to be universal. Furthermore, the specific timescales on which decoherence operates for different types of particles are exquisitely tuned. Large molecules can maintain quantum coherence for remarkably long periods under the right conditions, as shown in recent experiments, while dust grains collapse almost instantaneously. This isn't a random spread. It's a precise scaling that allows for complex quantum chemistry to occur in certain contexts while ensuring that everyday objects behave classically. We are only now, with our most advanced laboratories, beginning to probe and manipulate decoherence, to slow it down or shield systems from it to build quantum computers. The fact that it is a process we can interact with and control at all suggests it is a part of the universe's operational machinery, a piece of technology so fundamental we are just beginning to learn how it works. This idea of a universe built with precise, reliable technology leads us to a theory that views the cosmos not as a one-time creation, but as part of an endless, cyclical process of renewal. This is the concept of cosmic recycling technology, which suggests that our universe was not born from nothing, but was constructed using the raw materials and information harvested from a cosmos that came before it. It proposes that an advanced intelligence, perhaps one that survived the heat, death, or collapse of a previous universe, developed the ultimate form of sustainability, the ability to collect the remnants of a dead reality and use them as the foundation for a new one. This isn't just a theory of cosmic rebirth, it's a vision of hyper-advanced engineering operating across eons, turning the ashes of one universe into the seeds of the next. To grasp how this could work, we need to consider what remains when a universe ends. In one possible fate, the universe continues expanding forever, eventually succumbing to heat death. Stars burn out, black holes evaporate over trillions of years, and all that's left is a thin, cold haze of particles drifting further and further apart. In this vast, dark, and lifeless future, the most valuable resource wouldn't be energy or matter, but information. The theory suggests that a civilization could develop a technology to somehow imprint or encode the entire history and fundamental parameters of their dying universe onto these final, stable particles, perhaps neutrinos or even photons. This would be the ultimate act of preservation, a cosmic time capsule designed to survive the void. In another end scenario, a big crunch where the universe collapses back into a singularity, the technology might involve somehow harvesting the quantum information from that ultimate state of density, extracting the cosmic blueprint from the inferno just before everything is reset. The process of harvesting would be a feat beyond our comprehension. Imagine a technology that could navigate the absolute emptiness of a heat-dead universe, a network of probes or fields that could gently gather this encoded information without disturbing it. Or picture a civilization that has learned to manipulate the singularity of a collapsing universe, sifting through the ultimate density to find the data needed for a reboot. This harvested information wouldn't just be a historical record. It would be the essential code, the set of instructions and constants that define the previous reality. The intelligence behind this would then face the task of initialization. Using this salvaged code as a template, they could trigger a new Big Bang, perhaps by manipulating a quantum fluctuation in the void or by colliding brains in a higher dimensional bulk, carefully injecting the old information into the new expansion to guide the formation of a familiar, life-friendly cosmos. This provides an elegant and powerful explanation for the infamous fine-tuning problem. Why do the constants of nature seem perfectly set for life? Because they weren't set at random. They were selected. If a universe produces a civilization capable of eventually understanding and mastering cosmic recycling, that universe's parameters are, by definition, successful. Those specific settings, the mass of the electron, the strength of gravity, are the ones that get carried forward. They are tested and proven. Each cycle of cosmic death and rebirth becomes an evolutionary filter, where only the universes with the right laws for fostering complexity and intelligence get to have their blueprints recycled and reused. Our universe isn't fine-tuned by chance. It's fine-tuned by selection, potentially over countless previous iterations. We may be living in a universe that is the product of billions of years of cosmic natural selection, honed over endless cycles to be the perfect incubator for life and mind. The evidence for this incredible process might be hidden in the most ancient light we can see. The pattern of the cosmic microwave background, the leftover heat from our own Big Bang, could contain subtle imprints or anomalies, a faint signature or a pattern of correlations that doesn't quite fit our models of a universe born from nothing. Perhaps some property of the vacuum energy or the distribution of dark matter holds a clue, a relic structure that points to an origin that isn't entirely pristine. Furthermore, the mere existence of a universe that is comprehensible, that follows mathematical laws, could itself be a clue. If a universe were truly random, its laws might be chaotic and irrational. The profound mathematical order we observe could be the hallmark of a system that was designed and built from a pre-existing, well-ordered template. We are essentially reverse engineering the universe and finding a deep, consistent logic, which is exactly what you would expect if it were built from the recycled and refined plans of a prior reality. Now, if the cosmos is indeed a carefully engineered system, how do its various parts communicate and coordinate across such vast, impenetrable distances? This brings us to a particle so elusive it can pass through light years of lead without a single interaction, and a theory that proposes this isn't a flaw but a feature of its design. We are talking about the neutrino, and Theory 23 suggests these ghostly particles were engineered to form a cosmic neutrino communication network. To understand why they would be the perfect medium for this, we need to appreciate their bizarre properties. Neutrinos are born in the most violent and energetic events in the universe, the cores of exploding stars, the furious hearts of active galaxies, and the Big Bang itself. They are nearly massless, chargeless, and interact with ordinary matter only through the weak nuclear force, which has an incredibly short range. This means they are the ultimate tunnelers. A neutrino can slice through a planet as if it weren't even there, emerging on the other side completely unchanged and unaffected. This profound neutrality is what makes them the ideal cosmic messengers. Imagine trying to send a radio signal across the galaxy. The beam would spread out and weaken over distance. It would be absorbed or scattered by interstellar gas and dust, and it would be drowned out by the background radio noise from countless stars and nebulae. A laser beam is more focused, but it can still be blocked by any object in its path. A neutrino beam faces none of these problems. It does not diffuse or weaken over distance in the same way. It is virtually impervious to interference or obstruction, and it travels at nearly the speed of light. A message encoded in a stream of neutrinos could be sent directly from one side of a galaxy to the other, or even through the dense, blinding core of a star, arriving perfectly intact and perfectly on time. For a technology aiming to coordinate events on a galactic scale, this is the perfect solution. The engineering behind such a network would be staggering, but its potential applications are breathtaking. This could be the universe's backbone for real-time data transfer. The supermassive black holes at the center of galaxies, which we theorized might be engines or archives, could also be immense neutrino transmitters, broadcasting information about galactic evolution, stellar populations, or even warnings about impending cosmic events like supernova shockwaves or gamma-ray bursts. These signals would flow unseen through every star and planet, a hidden web of information connecting the most significant structures in the cosmos. Furthermore, the nearly instantaneous and unimpeded nature of neutrino travel would solve the problem of causality across vast distances. It would allow for a level of synchronicity and coordination that the limited speed of light makes impossible for any technology based on electromagnetic waves. For us, detecting these particles is a monumental challenge, requiring enormous, sensitive detectors buried deep underground to shield them from other forms of interference. But from the perspective of this theory, our difficulty in catching these cosmic messages might be another layer of the design. A neutrino-based network is inherently secure and private. It cannot be easily tapped into or disrupted by any civilization that hasn't reached a very high level of technological sophistication. The universe's most important communications could be happening all around us, flowing through our bodies and our planet every second, completely undetectable to our current technology. This isn't a network designed for young species like us. It's the secure channel for the architects or the mature caretakers of the cosmos, a silent, enduring testament to a technology that operates in plain sight yet remains perfectly hidden. But perhaps even a perfectly calibrated communication network requires a deeper, more fundamental layer of stability to function, a set of rules that governs the behavior of everything from the smallest particles to the largest clusters of galaxies. This brings us to a quest that has consumed physicists for nearly a century, the search for a theory of quantum gravity. Our 24th theory proposes that this isn't just an abstract scientific goal, but that the unification of quantum mechanics and gravity itself represents a primordial technological achievement. It suggests that the seamless integration of these two contradictory sets of laws was not a happy accident of nature, but a hard-won engineering marvel, the masterstroke that made a stable, long-lived universe possible. To understand the scale of this achievement, we need to appreciate the great divide in modern physics. On one hand, we have quantum mechanics, which describes the world of the very small with astonishing precision. It's a realm of probability, uncertainty, and discrete packets of energy. Its equations allow particles to be in two places at once, to tunnel through barriers, and to be spookily connected across space. On the other hand, we have Einstein's theory of general relativity, which describes gravity not as a force, but as the curvature of spacetime by mass and energy. It's a beautiful, deterministic theory that perfectly predicts the orbit of planets, the bending of light around stars, and the expansion of the cosmos. The problem is, these two monumental theories are fundamentally incompatible. They speak different mathematical languages and make contradictory claims about how reality works at its most fundamental level. Where they meet, at the center of a black hole or the moment of the Big Bang, our physics breaks down into nonsense. The quest for quantum gravity is the attempt to find a single, overarching theory that reconciles these two worlds. This theory posits that this reconciliation was accomplished long ago, not by us, but by the architects of our cosmos. The technological challenge would have been unimaginable. It would require finding a mathematical framework where the probabilistic, fuzzy nature of the quantum world could be seamlessly woven into the smooth, geometric fabric of spacetime. The solution, whatever its form, be it string theory, loop quantum gravity, or something we haven't yet conceived, would be the ultimate operating system. This quantum gravity technology would have been the first and most important tool deployed, the prerequisite that allowed all other cosmic technologies to function. Without it, the universe would be inherently unstable. The immense energy of the quantum vacuum would warp spacetime to catastrophic degrees, and the singularities at the heart of black holes would represent unmitigated disasters where the laws of physics simply cease to exist. A universe without a theory of quantum gravity is a universe that cannot hold itself together. The application of this technology would have been most critical in the universe's first fleeting moments. During the Planck epoch, a period of time so short it defies imagination, the entire cosmos was compressed into a volume smaller than a single atom. Here, the energy densities were so extreme that quantum effects and gravitational effects were one and the same. This was the moment of ultimate instability, a seething, chaotic foam where spacetime itself churned and fluctuated. It is here that the quantum gravity technology would have been activated, imposing order on this chaos. It would have provided the rules that governed how spacetime could emerge from this frenzy, smoothing out the wildest fluctuations and establishing a stable, expanding continuum. This process wouldn't just create space and time. It would define their very properties, determining whether the universe would be open or closed, finite or infinite, and setting the stage for everything that was to follow. Furthermore, this primordial unification would have been the essential enabler for the formation of all complex structures. The microscopic quantum fluctuations that were imprinted on the fabric of spacetime during this early period, the very seeds for all future galaxies, were themselves quantum gravitational phenomena. Their specific spectrum, their amplitude, their distribution across the sky, all of these properties were dictated by the unknown laws of quantum gravity. A different set of rules would have produced a different pattern of fluctuations, leading to a universe that was either too smooth to ever form galaxies or too lumpy, and prone to immediately collapsing into a swarm of black holes. The fact that we have a cosmos with just the right amount of lumpiness to create a beautiful cosmic web of galaxies and voids is a direct reflection of the specific quantum gravity technology that was employed. It was this technology that carefully dialed in the initial conditions, ensuring the universe would be neither sterile nor violent but fertile. In this light, every galaxy we see is a direct descendant and a permanent monument to that first, flawless act of cosmic engineering, a unification achieved so perfectly that its signature is written into the large-scale structure of the entire observable universe. This meticulous calibration of the universe's starting parameters brings us to a theory that asks us to look back not just to the first moments, but to the very first values, the initial settings that launched our entire cosmic story. This is cosmic initial conditions programming, the idea that the specific state of the universe at the instant of the Big Bang was not a random, arbitrary set of circumstances, but a carefully chosen and technologically implemented configuration designed with a clear purpose to guarantee the eventual emergence of galaxies, stars, planets, and conscious life. To appreciate the profound programming required, consider the universe's very first microsecond. It wasn't just hot and dense, it possessed a very specific set of properties that had to be exquisitely balanced. Two of the most critical were its initial uniformity and its expansion rate. The universe was incredibly smooth, with the density of matter and energy almost perfectly even across the entire cosmos. This might sound like a simple starting point, but it was absolutely essential. If the early universe had contained significant large-scale lumps or irregularities, gravity would have magnified those denser regions catastrophically, causing the entire cosmos to rapidly collapse into a swarm of giant black holes long before stars could ever form. Conversely, if it had been too smooth, a perfect vacuum with no variations at all, gravity would have had nothing to grip onto. The gas of the cosmos would have simply continued to thin out forever, never coalescing into the galaxies and stars that light up the night sky. The initial condition had to be Goldilocks perfect, smooth enough to avoid immediate gravitational catastrophe, but imprinted with just the right spectrum of minuscule quantum ripples to provide the seeds for all future structure. This leads directly to the second masterstroke of initial programming, the rate of expansion. The force of the Big Bang's outward thrust and the inward pull of gravity had to be balanced with a precision that is almost impossible to fathom. If the expansion rate had been even a tiny fraction slower, the universe would have quickly collapsed back in on itself in a big crunch after only a few million years, a cosmic blink of an eye, utterly insufficient for the slow, multi-billion-year process of stellar evolution and planet formation. If the expansion rate had been slightly faster, the primordial soup of matter would have flown apart so rapidly that particles could never have found each other to form even the simplest atoms, let alone complex galaxies. Gravity would have been defeated before the battle even began, leaving a cold, dark, and eternal emptiness. The fact that we exist in a universe that has persisted for 13.8 billion years, continuing to expand while still forming new stars, is a direct result of this impossibly precise initial setting of the expansion rate. We can find the evidence for this incredible fine-tuning imprinted across the entire sky in the cosmic microwave background. This ancient light shows us a universe that is almost perfectly uniform, yet contains those all-important tiny variations, the blueprint for everything to come. The statistical pattern of these hot and cold spots matches the predictions of a universe that began with exactly the right conditions for life with astonishing accuracy. From this perspective, the CMB is not just a fossil. It is the readout from the universe's original launch sequence, a permanent record showing that the initial parameters were set correctly. The subsequent evolution of the cosmos, the graceful dance of galaxy formation, the steady burning of stars, the peaceful orbits of planets, is simply the execution of a program that was flawlessly initialized and almost incomprehensible 14 billion years ago. This theory compels a staggering conclusion. The initial conditions were not a product of chance but of intent. The specific values for the density, the expansion rate, the matter-antimatter asymmetry, and the spectrum of quantum fluctuations appear to be a coordinated set of choices. They are interdependent settings on a vast cosmic control panel, each one carefully dialed in to complement the others and produce a single, stable outcome. This suggests a form of programming that transcends time, a technology that could operate from outside our conception of cause and effect to define the very rules of the game at time equals zero. The universe we inhabit, with all its beauty and complexity, may be the successful output of a cosmic algorithm whose first and most important line of code was a perfectly programmed set of initial conditions, ensuring that from the very first moment the story would inevitably lead to us. Yet woven through this grand cosmic architecture, invisible to our eyes but fundamental to its structure, is a force we are only just beginning to map and understand. This is the power of magnetism, and our 26th theory proposes that these fields are not a later byproduct of the cosmos, but a foundational technology, a primordial magnetic field cosmology engineered to shape the universe from its very first moments. We often think of magnetism as a local phenomenon, something that makes a compass needle point north or holds a child's drawing to a refrigerator. But on a cosmic scale, magnetic fields are titanic. They are detected threading through the vast voids between galaxies, permeating galaxy clusters, and coiled within the spiraling arms of individual galaxies. The puzzle for cosmologists has always been the origin of these immense fields. How did they grow to such a scale and strength? Conventional theories suggest they were seeded by tiny fluctuations in the early universe and then amplified over billions of years by the turbulent motions of plasma. But this process is inefficient and struggles to explain the magnetic fields we observe in the deepest, most empty regions of space. The theory of magnetic field cosmology offers a radical alternative. These fields were not grown from tiny seeds, but were woven into the fabric of the nascent universe itself as a deliberate act of engineering. The purpose of such a technology would be profound. On the largest scales, these primordial magnetic fields could have acted as a cosmic scaffold, a subtle but pervasive framework that guided the flow of matter during the formation of the cosmic web. In the early universe, gravity was the primary sculptor, pulling slightly denser regions of dark matter and gas into the filaments and nodes that would become galaxies and clusters. But gravity alone can create a chaotic and inefficient process. A pervasive, large-scale magnetic field would add a new directional force, channeling ionized gas along specific pathways and preventing it from scattering too widely. This would significantly enhance the efficiency of galaxy formation, ensuring that a greater percentage of the universe's primordial hydrogen and helium was successfully funneled into the potential wells of dark matter where it could eventually collapse to form stars. The magnificent spiral arms of galaxies like our own Milky Way, which are essentially waves of density and star formation, may owe their precise structure and stability in part to the ordering influence of these underlying magnetic fields, which help to organize the turbulent interstellar gas into coherent, rotating structures. The influence of this magnetic technology would extend right down to the cradle of individual stars. A star is born when a massive cloud of gas collapses under its own gravity. But this cloud also possesses angular momentum it's spinning. As it collapses, this spin accelerates, much like a figure skater pulling in their arms, creating a centrifugal force that can halt the collapse and prevent the star from forming. This is a major problem for star formation. Magnetic fields offer an elegant technological solution. The field lines threading through the gas cloud act like brakes, transferring the cloud's angular momentum outward and allowing the inner regions to continue collapsing to form the star. In this view, the omnipresent magnetic fields are a regulatory technology, a built-in system that ensures the efficient conversion of raw gas into new stars. Without this mechanism, star formation might be a far more rare and inefficient process, leaving the universe dark and barren. The fields don't just help stars form, they also govern their death. The powerful jets erupting from the poles of newborn stars and the spectacular blasts of supernova are all channeled and focused by magnetic fields, ensuring that the heavy elements forged in stellar cores are effectively scattered back into space to become the building blocks for future planets and life. This intricate feedback loop, essential for a fertile universe, appears to be guided by the invisible hand of magnetism, a hand that this theory suggests was deliberately placed there at the beginning. But if the cosmic magnetic fields provide a hidden framework for structure and the initial conditions set the stage, we must ask a more fundamental question about the nature of reality itself. How do possibilities become actualities? This brings us to the very edge of quantum theory and one of its greatest mysteries, the act of observation. Our 27th theory ventures into this enigmatic territory, proposing that the quantum measurement process is not a passive law of nature, but a sophisticated built-in technology. This is the idea of quantum measurement technology, which suggests that the infamous collapse of the wave function the moment a quantum possibility chooses a single, definite state is an engineered mechanism, a primordial tool designed to actualize potential into concrete existence. To grasp this, we need to step into the bizarre world of quantum superposition. Before a particle is measured, it doesn't exist in a single location or state. Instead, it is described by a wave function, a cloud of probability representing all the places it could be and all the states it could hold. An electron is not here or there. It is, in a very real mathematical sense, both here and there, existing in a blurred state of potential. This isn't a lack of knowledge, it's the particle's fundamental nature. The mystery deepens with the act of measurement itself. When we finally look, when we set up a detector to find that electron, this fuzzy cloud of possibilities instantly collapses. We find the electron in one specific place with one specific property. The question that has haunted physicists for a century is what causes this collapse? What transforms the and into an, or the conventional interpretations range from the conscious observer effect to the many worlds theory, where every possibility plays out in a branching multiverse. But quantum measurement technology offers a different technological resolution. The collapse is not a philosophical problem, but a designed feature, a built-in mechanism that forces the quantum world to make a choice, to translate possibility into the stable, classical reality we need to exist. The technological elegance of such a system lies in its perfect timing and reliability. If the wave function never collapsed, if quantum superpositions persisted at macroscopic scales, reality would be a blurry, incoherent mess. The chair you're sitting on would have a probability of suddenly being across the room. The atoms in your body would be smeared across space. Life, chemistry, and solid matter as we know them would be impossible. The measurement technology ensures that at a certain scale, when a quantum system becomes sufficiently entangled with its environment, a process known as decoherence, it is forced to resolve into a single, definite state. This isn't a bug, it's the universe's ultimate reality enforcement protocol. It creates a clear boundary between the quantum realm of potential and the classical world of actuality, allowing both to exist without interfering with each other. The quantum world provides the probabilistic magic that allows for nuclear fusion in stars and tunneling in semiconductors, while the classical world provides the stable stage for planets, people, and pointers on measuring devices. This perspective also reinterprets the role of the observer. In this technological framework, the observer doesn't need to be conscious. The technology itself is triggered by any interaction that records information in the environment. A photon bouncing off an atom and flying into space counts as a measurement. It forces that atom's state to collapse relative to the rest of the universe. This means the measurement technology is running continuously, everywhere, trillions of times per second, as particles constantly interact and decohere. It is an automatic, environmental process that maintains a consistent, shared reality for all of us. The difficulty we have in pinpointing an exact moment of collapse isn't a flaw in our understanding, but a testament to the seamless, ubiquitous, and invisible nature of this technology. It works so perfectly that we only notice it when we deliberately set up experiments to probe its limits, like the double-slit experiment, where the very act of trying to see which path a particle takes forces it to behave like a definite particle instead of a spread-out wave. Evidence for this extraordinary idea might be found in the specific mathematical rules that govern the collapse process. When a wave function collapses, it doesn't choose its final state at random. The probability of finding a particle in a particular location is given by the square of the amplitude of its wave function at that point. This is the Born rule, a fundamental postulate of quantum mechanics that has been confirmed with incredible precision in countless experiments. But why this rule? Why not some other probability distribution? From the viewpoint of quantum measurement technology, the Born rule isn't a mysterious mathematical given. It is the operating instruction of the measurement system. It is the algorithm that the technology uses to actualize one possibility from the many. The fact that this rule is so simple, universal, and effective that it seamlessly produces the statistical results we see in the lab points toward a designed mechanism rather than a random accident. The measurement problem isn't a paradox to be solved, but a piece of cosmic engineering to be reverse engineered. A technology so fundamental that we are living inside its output every moment of every day. Now we arrive at a theory that asks us to contemplate the most fundamental settings of our reality, the very numbers that define existence itself. This is the investigation into cosmic constant fine-tuning, the staggering notion that the fundamental physical constants, the immutable numbers that govern the behavior of every particle and force, were not randomly assigned, but were technologically determined with unimaginable precision to create a universe capable of supporting complexity, structure, and ultimately, life. These constants are the universe's non-negotiable rules. They are not derived from any deeper theory. They simply are. Their values seem arbitrary, yet if any one of them were altered by even a vanishingly small amount, the consequences would be utterly catastrophic, rendering the cosmos sterile, unstable, or stillborn. Consider the cosmological constant, often associated with the energy of empty space that drives the universe's accelerating expansion. The value we observe is so astoundingly small that it has been called the worst prediction in the history of physics. Quantum theory suggests the vacuum should be boiling with an energy density that would have torn the universe apart in its first fraction of a second. Yet, the observed value is roughly 120 orders of magnitude smaller. This is not just a minor discrepancy, it is a numerical chasm so vast it hints at a cancellation of almost perfect precision. If this constant were even slightly larger, its repulsive force would have overcome gravity immediately after the Big Bang, preventing any matter from clumping together into galaxies, stars, or planets. The universe would be a cold, expanding void of isolated particles. If it were significantly smaller and negative, the universe would have collapsed back in a big crunch after only a few million years. The fact that it is precisely tuned to allow for billions of years of structure formation before gently taking over to drive acceleration is a coincidence so miraculous it begs for an explanation beyond chance. Equally precise is the fine structure constant, a mysterious dimensionless number that governs the strength of the electromagnetic force. This constant, approximately 1/137th, controls how tightly electrons are bound to atomic nuclei, dictating the entire field of chemistry. If this value were just a few percent larger, atomic nuclei would attract electrons so strongly that all stars would burn their fuel in a fleeting, furious burst, collapsing into stellar corpses long before planets could form. Proton fusion would occur at lower temperatures, meaning stars could form from cold hydrogen gas, leading to a universe of short-lived, chaotic stellar explosions. If the fine structure constant were slightly smaller, electromagnetism would be too weak to hold atoms together at all. Chemical bonds would be impossible, and matter would remain a diffuse, non-reactive gas. The specific value we observe allows for the stable atomic orbits, the complex molecular bonds of DNA and proteins, and the long, steady fusion processes in stars that provide the energy and time necessary for life to evolve. It is a number that sits in a razor-thin golden zone, permitting a rich and interactive material world. This fine-tuning extends far beyond these two famous examples. The strength of the strong nuclear force which glues atomic nuclei together is also exquisitely balanced. If it were slightly weaker, simple hydrogen would be the only element, as no other nuclei could form. There would be no carbon, no oxygen, no building blocks for life or rocky planets. If it were slightly stronger, protons could bond directly into diprotons, causing all the hydrogen in the early universe to fuse into heavier elements almost instantly. This would leave no long-lasting fuel for stars, and the universe would be devoid of the stable hydrogen-burning suns that provide hospitable environments for life. Even the mass of the neutron is perfectly calibrated. It is just slightly heavier than the proton, allowing free neutrons to decay and preventing the universe from being dominated by neutron-rich inert matter. If the neutron were lighter, protons would decay into neutrons and atoms as we know them would not exist. This concatenation of perfect values forms a deeply interlocking set of requirements. It is not merely one constant that is set correctly, but dozens, all perfectly aligned to permit the same outcome, a stable, long-lived and complex universe. The probability of this occurring by random chance is so infinitesimally small that it strains credulity. This is the heart of the fine-tuning problem, and it leads us to a powerful technological interpretation. Perhaps these values were not lottery numbers drawn at random from a cosmic hat. Instead, they could represent the final, optimized settings on a cosmic control panel, the result of a process of technological determination. A prior intelligence or a design process could have calculated the necessary parameters for a viable universe and then implemented them with flawless precision at the moment of creation. The constants are not arbitrary. They are the architectural specifications, the carefully chosen inputs that guarantee the output will be a cosmos teeming with galaxies, stars, planets, and the potential for consciousness. The universe appears fine-tuned for life because from this perspective it literally was. But what is the currency of this ultimate computation, the fundamental substrate upon which it runs? This leads us to a theory that proposes a radical reordering of reality's foundations, placing not matter or energy at the base of existence, but something far more abstract and powerful, information itself. This is information theory cosmology, the idea that the universe is not merely made of particles and forces, but is fundamentally an information processing system. In this view, the bits and bytes are not a metaphor. They are the true bedrock of existence, and the physical world we see is a magnificent manifestation of data being processed according to a set of primordial algorithms. This perspective forces a complete shift in how we see everything. Consider a physical object a simple rock. A traditional physicist would describe it in terms of its mass, its chemical composition, the energy states of its atoms. An information theorist would describe it as a highly ordered, low-entropy state, a specific and intricate arrangement of information. Every atom, with its specific type and position, represents a bit of data. The forces holding it together are the rules governing how that data can interact and be processed. From this vantage point, the entire cosmos is a vast, dynamic data structure. A star is not just a ball of fusing plasma. It is a localized, intense processing node that takes the simple information of hydrogen and transforms it into the more complex information of heavier elements. A black hole with its event horizon becomes the universe's ultimate information storage device, holding an amount of data proportional to its surface area. Even the passage of time can be reinterpreted not as a flowing river, but as the sequential processing of information, a cosmic clock cycle where the state of the universe is calculated from one moment to the next. The implications of this are nothing short of revolutionary for the fine-tuning problem. The precise values of the physical constants, the strength of gravity, the mass of an electron are no longer seen as mysterious, arbitrary numbers. Instead, they are the essential, fixed parameters of the universe's operating system. They are the unchanging rules of the computation, the algorithms that dictate how information can be transformed and moved. The fact that these values allow for complex structures like galaxies and life forms is not a miracle. It is the signature of a stable and fertile information processing environment. A universe with different constants would simply be running a different, and likely far less interesting, program one that might terminate immediately or simply loop in a featureless void. Our universe's laws are the ideal set of instructions for generating maximal complexity and long-running computation. This view finds a powerful and elegant expression in the holographic principle, a concept arising from the study of black holes and quantum gravity. It suggests that all the information describing a three-dimensional volume of space, everything within it, is actually encoded on its two-dimensional boundary. Imagine the universe as a hologram where a three-dimensional image is projected from a flat, two-dimensional surface. The mind-bending conclusion is that we, and everything we see, might be a projection from information stored on the outermost boundary of the observable universe. This would mean that the true nature of reality is not three-dimensional and physical, but two-dimensional and informational. The physical world is a derivative reality, a user interface generated from a deeper layer of information processing happening at the edge of space and time. If this is true, then the search for a final theory of physics transforms into the search for the universe's source code. The goal is not to find a smaller, more fundamental particle, but to discover the primal programming language and the algorithms that are being executed. The mathematical laws we have uncovered, the elegant equations of general relativity and the precise probabilities of quantum mechanics, are not laws in the sense of decrees that matter must obey. They are the discovered logic of the cosmic program, the high-level code we are reverse engineering. The ultimate technology, then, is not a device or an engine, but the informational architecture itself, a self-executing, self-referential system that from a simple set of initial inputs and rules generates the breathtaking complexity and beauty of the cosmos. We are not just living in a universe that processes information, we are living inside the processing. This brings us to our final and perhaps most profound theory, one that synthesizes many of the ideas we've explored into a grand, unified vision of a cosmos with a purpose. This is the concept of cosmic evolutionary guidance, the idea that the universe is not a passive stage but an active participant in its own story, equipped with built-in, technological mechanisms designed to steer its evolution inexorably toward greater complexity, consciousness, and intelligence. It suggests that the journey from the Big Bang's primordial fire to the emergence of self-aware minds is not a series of lucky accidents, but a guided pathway, a cosmic curriculum written into the very laws of physics to ensure that life and mind eventually become a natural part of the universe's expression. We can see the fingerprints of this guidance system in the universe's stunning capacity for self-organization. From the very beginning, simple rules have given rise to breathtaking complexity. Gravity, the weakest of the fundamental forces, slowly and patiently gathered the faint ripples in the cosmic microwave background into vast webs of dark matter. Gas flowing along these invisible gravitational rivers collapsed to form the first stars. These stellar engines then performed the universe's next great trick, nucleosynthesis. Within their furious hearts, they fused simple hydrogen and helium into the heavier elements essential for planets and life: carbon, oxygen, nitrogen, iron. When these first stars died in cataclysmic supernova, they did not simply vanish. They scattered these newly forged elements across space like a gardener sowing seeds. This process is a perfect example of a guided feedback loop. The first stars created the necessary ingredients for the second generation of stars, which were born with a richer blend of elements, allowing for the formation of rocky planets. Each cycle of stellar life and death enriched the cosmic environment, creating the conditions for the next, more complex phase of evolution. This guidance continues on a planetary scale. Consider the conditions that allowed life to emerge and thrive on Earth. Our planet orbits at a perfect distance from a stable, long-lived star. It has a large moon that stabilizes its axial tilt, preventing chaotic climate shifts. Its molten core generates a protective magnetic field, shielding the atmosphere from being stripped away by solar winds. plate tectonics recycle minerals and regulate global temperatures. From the perspective of cosmic evolutionary guidance, this is not a checklist of fortunate circumstances. It is a suite of planetary-scale technologies working in concert to create and maintain a stable incubator for billions of years. The universe, through its physical laws, has built-in systems for generating and preserving habitable worlds. The apparent fine-tuning for life is not a mystery. It is the expected outcome of a universe programmed to produce biospheres. The guidance system's most sophisticated achievement, however, may be the way it appears to funnel complexity toward consciousness itself. Evolution by natural selection on Earth is often portrayed as a blind, random process. But what if the parameters for that process were set by the cosmos at large? The laws of chemistry dictate which molecules can form and how they interact. The very properties of water, carbon, and DNA make them uniquely suited for storing information and building complex structures. These are not biological accidents, they are chemical inevitabilities given the universe's fundamental constants. Life, in this view, emerges not as a statistical miracle, but as a phase of matter, a natural and almost inevitable consequence of a universe whose laws are primed for complexity. And once life emerges, the evolutionary process itself is guided by the relentless engine of natural selection, which favors greater information processing, adaptability, and eventually intelligence. The universe seems to have a bias for creating systems that can better understand and interact with it, from the first self-replicating molecule to the complex neural networks of the human brain. This theory offers a powerful and uplifting resolution to the question of our place in the cosmos. We are not insignificant, lonely accidents in a vast and indifferent void. Instead, we may be a flowering of the universe's innate potential, a manifestation of a billion-year guidance system written into the code of reality. Our drive to understand the cosmos, to build telescopes that peer back to the beginning of time and particle accelerators that probe the fundamentals of matter, is not a separate human endeavor. It could be the universe becoming conscious of itself, fulfilling a deep-seated purpose that was embedded at the moment of creation. The technologies we are now developing, from artificial intelligence to genetic engineering, might not be a divergence from nature, but the next logical step in this guided cosmic evolution. We are not just inhabitants of this universe, we are participants in its grand, unfolding story, perhaps even the instruments through which it will ultimately understand its own origin and destiny. From the cosmic seed algorithm that may have initiated the Big Bang itself to the intricate quantum field engineering that defines every particle and force, the theories we've explored today paint a picture of a universe that is far more than a collection of random accidents. They suggest a cosmos that was built with intention, precision, and a breathtaking level of sophistication. Whether it's the dark matter scaffolding holding galaxies together, the quantum entanglement network connecting every corner of existence, or the biological coding that seems to guide evolution from stars to consciousness, these ideas point toward a reality that is fundamentally technological in nature. We are not just living in a universe, we are living inside the greatest piece of engineering ever conceived, a system that has been running flawlessly for nearly 14 billion years. What does this tell us about the nature of reality? It suggests that the universe is not a cold, empty void, but a deeply structured and intelligible system. The fact that we can uncover these mathematical laws and even contemplate these possibilities is itself a profound clue. We are not separate observers looking in from the outside. We are a product of this cosmic technology, the universe's way of becoming aware of itself. Our search for meaning is not a futile struggle against an indifferent cosmos, but perhaps the very purpose for which the cosmos was built. The fine-tuning of constants, the guidance of evolution, and the emergence of consciousness all point toward a reality that is not just hospitable to life, but actively fosters its growth and complexity. These concepts are more than just scientific speculation. They are invitations to expand our perspective on everything. They challenge us to see the world not as a given, but as a constructed environment filled with clues and signatures waiting to be decoded. The next time you look up at the night sky, consider that you might be gazing upon the ultimate engineering project, a masterpiece of design whose architects operated on a scale and with a technology we are only beginning to imagine. Now, we want to hear from you. Which of these 30 theories resonated most deeply with you? Was it the holographic principle that suggests we live in a projected reality, the idea of cosmic DNA, or the mind-bending possibility that consciousness itself is a built-in feature of the cosmos? Share your favorite in the comments below and tell us why it captures your imagination. The conversation about our origins is one of the most important we can have, and your perspective is a valuable part of it. If this journey to the edge of understanding left you craving more, there are incredible resources to dive into next. For a deeper look at the fine-tuning of the universe, books like The Cosmic Landscape by Leonard Susskind or The Goldilocks Enigma by Paul Davies offer brilliant insights. To explore the simulation hypothesis and information theory cosmology, Our Mathematical Universe by Max Tegmark is a fantastic read. And of course, the frontiers of this research are always expanding, with new papers published constantly on platforms like arXiv.org. The mysteries of the cosmos are endless, and this is just one of many conversations we're having about them. If you want to keep exploring the biggest questions about reality, existence, and the future of technology, make sure to subscribe and hit the bell so you don't miss our next video. Thank you for joining us on this incredible journey to the very limits of science and imagination. Keep wondering.